Okay, so here are the equations for the reaction distance and the braking distance. All right. This is the reaction distance equation. This is the braking distance equation. Combined, they make up the stopping sight distance. The amount of time it takes for you to react to a situation, react to it, and then make some type of action, and then complete that action. So the stopping sight distance. As we said before, the speed is represented in miles per hour. You know, your reaction time before design, especially when we're designing for highways, we use a reaction distance equal to 2.5 seconds for design of the highways. This right here is just a conversion factor as well as this is from miles per hour to feet per second. And then this term right here you've heard me refer to as a friction factor, which is also equal to the deceleration rate over gravity. Now, we've talked about the deceleration rate that we assume, which is 11.2 feet per second squared. And then, of course, gravity is 32.2 feet per second squared. What that all equates to is 0.348. All right, assuming that that remains the same, and of course that's always going to remain the same. The last term here is grade, and this grade is going to be represented in decimal form. So the percent grade in decimal form. Now, if this is given to you at 4%, then you're going to use a 0.04. It should never be a whole number. It should always be some type of decimal number for this type. All right, so for example, I want to be able to use a downhill and an uphill situation. So in this example, we have a vehicle traveling downhill on a slope that's about 4%. As you can see here, what I use or what I changed in this equation is this term to 0.348, because I'm just going to assume that it's decelerating 11.2 feet per second squared, and then I'm subtracting 0.04 because it was a downhill of 4%. Now on the opposite side of things, we have a vehicle that's traveling uphill. So the braking distance, again, we're only talking about the braking distance. We haven't even factored in this yet. But the braking distance side of this equation is going to be equal to the speed squared divided by this constant term here, 0.348. And then I will be adding, because I'm going uphill, I'm going to be adding a 0.03 because it's 3%. Now what you'll see here is whether you're going uphill or downhill will determine how long it would take for you to brake once your foot touches the brake pad or brake pedal. Of course, if you're going uphill, gravity is working against you, and therefore this number should probably be lower. But if you're going downhill, gravity is working with you, so it'll take longer for you to stop, and this number will be higher. The only reason why this one might not be lower and this one might not be higher is because of the percent grades. So you see here two things are at play: the downhill or uphill and the percent grade at which you're going downhill or uphill.